In this video, what we are going to see is about carbonyl compounds. Explain the structure of carbonyl group. Write ozonolysis of alkene or how carbonyl compounds can be prepared from ozonolysis reaction or ozonide compound. The next one is how to convert alkynes into carbonyl compound, how to prepare a carbonyl compound from alkynes. That is conversion or how to convert acetylene into acetaldehyde. How to prepare carbonyl compound from dry distillation of calcium salts, that is conversion of acetone into calcium ethanoate. What is Rosenmund reduction or what is Rosenmund reduction or what is the use of barium sulfate for palladium catalyst in Rosenmund reduction. Write Stephen's reaction, how to convert alkyl cyanide into acetaldehyde. So these are all the questions we are going to see in carbonyl compounds. The structure of carbonyl group. Explain the structure of carbonyl group. Carbon is of valency 4. Here the carbonyl group C double bond O. The C double bond O in which the carbon is present in sp2 hybridized status. The C double bond O in carbonyl group is similar to that of C double bond C in unsaturated compound. This carbonyl compound sp2 hybridized making 3 sigma bonds with the other atoms. CO 1 sigma bond, CH if it is aldehyde means 1 sigma bond, C alkyl group 1 sigma bond. So if it is aldehyde means CHO, if it is ketone means 2 alkyl group. So thereby carbon making sigma bond with the 2 alkyl group. So the 3 valency of carbon is satisfied. The 4th valency electron of carbon, as it is the valency is 4, the 4th valency carbon remain unhybridized in the 2p orbital which lays perpendicular to the plane of the sigma bond. So it forms a pi bond with the oxygen atom and the unhybridized orbital present in the oxygen atom, that is pi bond. Carbon oxygen pi bond is formed. So 3 sigma bond and 1 pi bond in C double bond O carbonyl group. And also the oxygen atom has 2 non-bonding pair of electron after the carbonyl bond formation. So the 2 carbonyl group electron, along with that the oxygen is most electronegative than that of carbon. So it has the tendency to pull the shared pair of electron towards itself, making the polarity between carbon and oxygen. So the bond, carbon-oxygen bond become polar because of the high electronegativity of oxygen. The shared pair of electron transfer to this oxygen, making the negative and carbon positive. The polarity is present. This polarization, the polar nature of the carbon-oxygen bond, responsible for the or contributes for the reactivity of aldehydes and ketones during the chemical reaction. The next one is how to prepare aldehydes and ketone from ozonolysis or ozonide intermediate or preparation of aldehydes and ketone from alkenes. 1, 2, 3, 4. The second place 2-butene. 2-butene on addition with ozone, the ozone gets adds up in the unsaturated position forming ozonide intermediate. On hydrolysis in the presence of zinc, the ozonide intermediate, the cleaved get cleaved in the bridge position forming CH3CHO, CH3CHO. And the H2 on hydrolysis, the H2 adds up with the oxygen and forming H2O2. CH3CHO, CH3CHO. So 2 acetaldehyde molecule and hydrogen peroxide. So and here the second reaction in this place one methyl group gets substituted. So 2 butene, here the methyl group substituted 2-butene or butene. When adds up with the ozone, the ozone gets substituted in the unsaturated place, it forms the ozonide intermediate. This ozonide intermediate on hydrolysis in the presence of zinc get cleaved in that bridge place. CH3CHO, the substituted methyl comes here and forms CH3COCH3, acetone is formed. So one acetaldehyde molecule and one acetone molecule, H2O plus O, H2O2 is formed. So 2-butene forming ethanol acetaldehyde. So 2-methyl-2-butene forms propanone, ketone. The next one is hydration of alkane by using 1% mercuric sulfate and 40% sulfuric acid, ethyne, acetylene, common name acetylene, and IUPAC name ethine, 2 carbon atom, triple bond. So hydrolysis, hydrogen goes to this first carbon, OH go to the second carbon, forming enol. Unsaturated alcohol enol is formed in the presence of this hydrolysis reagents. 40% dilute sulfuric acid, 1% mercury sulfate. This is an intermediate, enol intermediate is unstable one. Isomerizes, so this hydrogen moves to this carbon because of this attraction and forming, moving in CH3CHO. So ethanol, acetaldehyde is formed. So conversion of acetylene into acetaldehyde by using this reagent, or conversion of ethine to ethanol. So hydration of alkane into aldehydes. The next reaction is the methyl acetylene. Acetylene means CH triple bond CH is acetylene. In that, instead of one hydrogen, one methyl group substituted, methyl acetylene, or 1, 2, 3, 3 carbon atom, prop 1 ene, propine. So on reaction with hydrolysis, in the presence of 40% sulfuric acid, 1% mercury sulfate, hydrogen goes here and OH moves there, thereby forms CH3COHCH2, CH3COHCH2. This unstable one, the enol isomerizes to form hydrogen, this hydrogen moving here, forming CH3, then the double bond moves over here, forming CH3, C double bond O, CH3. Propanone is formed. So methyl acetylene forms acetone. 1, 2, 3, propanone. No, propanone or acetone. So methyl acetylene to acetone or prop 1 ene to propanone is formed by using 40% sulfuric acid and 1% mercuric sulfate, the conversion of alkyne into ketone. The next one is preparation of aldehydes and ketones from dry distillation of calcium salts. Depends upon the nature of salt what we are taking, the product will be formed. Calcium salts, the calcium possesses the valency of 2, thereby it combines with the two ions. For example, formic acid, if it is formate ion means HCOO. Calcium combines with the 2 formate ion forming calcium formate. On dry distillation, this calcium salt, removal of CaCO3, the remaining one is formaldehyde, and aldehyde is formed, dry distillation. If it is acetic acid means the formula of acetic acid is CH3COOH. Formate ion means CH3COO minus 2 formate acetate ion combines with the calcium forming calcium acetate. 2 acetate ion, here this side calcium formate according to its valency. From this, 2 calcium carbonate and 2 acetaldehyde formed. How it is formed is, here the one CaCO3, one calcium carbonate, the another calcium carbonate is CO3. So 2 calcium carbonate removed, the remaining is CH3CHO. 2 molecules of acetaldehyde, or ethanol, 2 carbon ethanol. So calcium ethanate and calcium ethanate and dry distillation forming ethanol, calcium carbonate. If it is phenyl group means, here then it will be phenyl group. For example, if it is methyl group means, here it will be methyl group, then it will be a acetophenone will be formed. So depends upon the calcium salt nature, reactant, and the product will be different. Here the calcium acetate, CH3COO. If it is phenyl group means benzophenone, C6H5COCH, benzophenone will be formed. So calcium acetate, CaCO3, calcium carbonate removed, here the acetone is formed. So from calcium ethanoate, propanone is formed. So dry distillation of calcium salt of acid, depending upon the nature of the reactant, the product aldehyde and ketone will be formed. Rosenmund reduction, one of the important reaction of preparation of aldehyde. Acetic acid, the formula ACH3COOH. In that, instead of OH, the Cl group is present. The derivative of acetic acid called acetyl chloride, CH3COCl. This acetyl chloride, in the presence of palladium and barium sulfate, the reduction takes place, addition of hydrogen takes place, hydrogen adds up here and H and Cl reacts removed as HCl, the hydrogen adds up forming acetaldehyde. So, the conversion of acetyl chloride into acetaldehyde in the presence of palladium and barium sulfate catalyst is called Rosenmund reduction. What is the use of barium sulfate for the palladium catalyst is, the palladium is the active catalyst, it may convert or reduce the formed acetaldehyde into alcohol. If aldehyde reduces, then it will form alcohol. To reduce the activity of palladium, the barium sulfate is used. Conversion of acetyl chloride into acetaldehyde in the presence of palladium barium sulfate, Rosenmund reduction. Next one is Stephen's reaction, conversion of methyl nitriles into acetaldehyde. It takes place in the two steps. The first one is addition of hydrogen, the second one is addition of water. The first one is addition of hydrogen, the second one is addition of water. So, the methyl cyanide, methyl nitrile, stannous chloride, hydrochloric acid, one hydrogen here, one hydrogen here. So, CH3CHNH, the addition of water, H2O, CH3CHO, NH3. So, first step addition of hydrogen, second step the addition of water, reduction followed by hydrolysis gives acetaldehyde, methyl cyanide into acetaldehyde, called Stephen's reaction. So, imines are formed that hydrolyze to aldehyde. Here also selective reduction by cyanide, diisobutyl aluminum hydride, DIBALH, selectively reduces alkyl cyanide into imines and followed by hydrolysis give aldehyde. Hex 4-ene nitrile, CH3CH double bond CH, CH2 CH2 CN. So, this hex 6 carbon. So, hex 4th place here unsaturation is present. CN thereby nitrile. So, by using the catalyst, reduction followed by hydrolysis gives hex 4-enal. So, acetaldehyde is formed. So, this reaction is called, by using the diisobutyl aluminum hydride, selective hydrolysis gives aldehyde, reduction followed by hydrolysis. So, Stephen reaction, methyl cyanide, methyl nitrile into acetaldehyde by using stannous chloride, hydrochloric acid, reduction followed by hydrolysis, conversion of acetyl chloride into acetaldehyde by using palladium barium sulfate catalyst, reduction, Rosenmund reduction. So, dry distillation of calcium salt of fatty acids, the preparation of aldehyde and ketone depends upon the reactant substance what we are taking. The conversion of alkyne into aldehyde or ketones by using 1% mercuric sulfate and 40% sulfuric acid. Conversion of that ozonide intermediate into the aldehyde and ketone, or conversion of alkene into aldehyde and ketones. Then the structure of carbonyl group. Subscribe for more videos. Thank you.